Welcome to the mesmerizing world of 3D graphics. Have you ever wondered how games like this bring such vivid and dynamic worlds to life? How do they transform simple shapes into these incredible visual spectacles? In today's video, we'll dive into the magic behind 3D graphics and reveal the secrets that make it all possible. But here's a mind-blowing fact. Your screen is actually just a flat, 2D surface. It has no depth, no 3D. Everything you see is made up of tiny points called pixels, and each of them can only show one color at a time. Consists of red, green, blue. Imagine a simple 2D grid with coordinates ranging from -1 to 1. This is the world our computer understands. Let's start with the basics. A triangle. In our 2D grid, we place 3 points and connect them to form a triangle. Simple, right? But this is just the beginning. Next, we can fill this triangle with colors using a process called rasterization. This drawing is made by shaders. Vertex shaders set positions, fragment shaders set colors. But plain colors can be limiting. To add more detail and variation, we use textures. Textures allow us to apply images to our shapes, making them look more interesting and complex. To create more complex shapes, we can combine multiple triangles. Here, we form a rectangle by adding a second triangle. By the way, modern GPUs are designed to render millions of triangles each frame and do this 60 times every second for smooth, realistic graphics. Now, watch as we change the rectangle's size to become a square. This transformation requires precise calculations. Calculating these 2D vertex screen coordinates manually involves complex math. Next, we transition to a third-person perspective using a camera helper, revealing the depth of our 3D scene. Picture a cube oriented to face directly towards this camera. Zooming into the camera's viewport, you'll see the cube's vertices projected onto the screen, perfectly matching its 2D representation. This illustrates how 3D objects are transformed into realistic perspective-correct images on screen. Calculating these 2D coordinates involves complex mathematics wrapped into simple logic. It's the result of multiplying the vertex matrix, which includes position, scale, and rotation, by a 4x4 matrix representing the camera's projection and view transformations. This process ensures accurate rendering of 3D scenes, bringing virtual environments to your 2D screen. With the next step, let's add some realism with lighting and shadows. Watch as a horizontal plane appears and a directional light smoothly increases intensity. Notice how one face of the cube brightens while the opposite face darkens, emphasizing the light source's direction. It depends on an angle between the face normal vector and the light direction vector. Vector multiplication is a crucial and very lightweight math operation in 3D calculations, replacing cosinus and sinus functions. Are you already feeling the potential of 3D graphics? This light also casts a shadow on the plane, adding depth and authenticity to our scene. Now let's step back and look at different rendering styles. The most popular are ray tracing. For example, modern AAA games like Cyberpunk utilizes complex calculations to simulate realistic lighting and reflections by tracing the path of light rays through pixels. Photorealistic rasterization. For example, previous generation of AAA games like Battlefield series employs traditional rasterization techniques with advanced shaders and lighting models, like PBR, to achieve high levels of realism. Voxel rendering, for example Minecraft, uses 3D cubes, voxels, to create a blocky, pixelated visual style, focusing on volumetric representation. Low poly rendering, for example Monument Valley, involves using low polygon meshes to create a clean, minimalist aesthetic, often with flat shading. Now, let's dive into UV mapping, a crucial technique for adding textures to 3D models. Imagine unwrapping a globe into a flat 2D map of the Earth. This process assigns 2D texture coordinates, U and V, to the 3D model's vertices, allowing us to wrap a detailed image around the surface of the model accurately. It's like transforming a globe into a flat map and back again. Next, we'll apply the same process to a complex object like a tank turret, demonstrating how UV mapping can handle intricate shapes, ensuring every detail fits perfectly on the 3D surface. Ever wondered how game characters have such detailed clothing and skin textures? That's the magic of UV mapping. What's your favorite game with stunning textures? Having explored UV mapping, we turn to another crucial aspect of 3D graphics: static and skinned meshes. Static meshes are rigid objects that don't move or deform. These include architectural elements like buildings, bridges, and roads, as well as smaller objects like furniture, trees, and vehicles. Static meshes are the backbone of any 3D environment, providing a stable and unchanging structure to the scene. Static meshes are highly optimized for rendering because their lack of movement allows for efficient use of resources. They can be pre-computed and stored in memory, enabling the graphics engine to quickly draw them without recalculating their positions or shapes. This efficiency is essential for maintaining high performance in complex scenes with many objects. Examples of static meshes include the detailed facades of city buildings, the intricate patterns of a tiled floor, or the lush foliage of a forest. Each of these elements adds to the richness and realism of the environment, creating a believable world for characters to inhabit. In contrast, skinned meshes are dynamic and flexible, designed for objects that need to move and deform. These include characters, creatures, and other animated objects. Skinned meshes are rigged with a skeleton, and each vertex is influenced by one or more bones, enabling fluid and lifelike movements. This technique is essential for bringing characters to life, making them run, jump, and interact with their surroundings convincingly. For example, when animating a character, the skinned mesh bends and twists according to the skeleton's movements, creating a natural flow. This process is crucial for cutscenes, gameplay animations, and any scenario where realistic motion is needed. The distinction between static and skinned meshes is key to creating believable and interactive 3D worlds. Static meshes build the environment, providing a rich and stable backdrop, while skinned meshes add life and dynamism, ensuring that everything from a towering skyscraper to a hero's triumphant leap looks and feels real. As we wrap up, I'm excited to share my app designed for food and fitness enthusiasts. It features realistic exercise animations using skinned meshes, perfect for mastering your workout routines with precision. Whether you're into fitness or exploring healthy recipes, this app has something for everyone. If you're curious, check out the link in the description below to explore and support us. Your feedback is invaluable in shaping our future updates, and I look forward to hearing from you. Now, see UV mapping in action with our 3D tank game. As the tank moves, observe how the textured skin seamlessly wraps around the model. The tracks move forward and backward dynamically through texture UV offset changes, while the deformation, wheel rotation, and positional changes are handled by the bones and skinned mesh system. UV mapping ensures every detail, from the tank's armor to its moving parts, looks natural and immersive. This technique is essential for bringing our virtual worlds to life with authenticity and detail. Watch as 3D tank game, Tank Arena, comes to life with intense gameplay. Navigate through challenging terrains, showcasing the game's immersive graphics and dynamic mechanics. Help me secure the future of Tank Arena. I'm on a mission to reclaim the rights to this epic game and make it better than ever, and available to public for free. With your support, I'm aiming to raise $10,000 to make this dream a reality. Every purchase on the Jachin.ai app gets me closer to my goal. Download the app today and purchase any item to contribute directly. Together, let's bring Tank Arena to new heights. What topics would you like me to cover next? Let me know in the comments below. And as always, thanks for watching.